This is VO1RFX, and here's what's on the bench today. Today we have a TF2300BM FM and AM modulation meter made by Marconi Instruments. That's kind of a mouthful, so I'll shorten it to an impulse buy. I wouldn't necessarily say that an FM AM modulation meter like this is exactly the highest priority item for me in terms of things that I need on my workbench, but when something like this comes along on the local classifieds for a really good price, well, it's kind of hard to pass up, and sometimes you've got to do what you've got to do. This project is going to span multiple videos. The reason is that there's a lot of ground to cover, and it spans a lot of different topics. They don't really all belong in the same video. So in this video, it's kind of just going to be an introduction as well as talking about what the game plan is going to be. So if you don't hear something covered in this video and you're kind of wishing for a bit more breadth or depth or both, don't worry, there's probably going to be a video about a particular subject that you're interested in coming out at a later date. For example, one of the many things we could do an entire video on is the operation of the unit and the technical specs, and almost a review essentially. And for now, I'll just kind of cite some things from the manual just to give you a bit of an overview, a little taste of what this unit actually does and what it's capable of. But we'll leave the really in-depth stuff, especially the operation, for another time. Likewise, we won't be opening the unit or powering it on or anything like that today, nor will we be repairing anything. Those all belong in separate videos. So, true to the name, it is an FM and AM modulation meter, so it measures FM deviation and AM depth. One interesting part about this is that you can actually use it for stereo FM broadcast transmitters and measure things like distortion and channel separation on a stereo transmitter. I don't actually have any use for any of that, but it's kind of cool that the unit is capable of doing that. One other nice feature is that there are IF outputs and a demodulated output as well. So in addition to getting the reading on the meter, you can also get a signal out for further analysis. The headline feature, I suppose you'd call it, is the frequency range that's supported by this piece of test equipment. As you can see by the frequency range dial here, it ranges from 4 to 1200 megahertz, although the information in the manual seems to suggest that the full range is actually only for FM, whereas AM is limited to 4 to 400 megahertz. However, the manual also states that you can go above 1200 megahertz with the use of an external oscillator. Similarly, you can also operate below 4 megahertz according to the manual by not using the local oscillator. Additionally, there's an optional accessory for this unit, which I'm quite happy to say is included on mine. It's the TK2302, and it's a add-on board that goes into the front panel here, and it allows you to use crystal oscillators, and that's what this leftmost option on this oscillator selection dial is for. It's a little bit confusing though. They mention that the crystal oscillator is ideal for high frequency measurements, whereas the same manual also states that the frequency range of this crystal oscillator option is limited quite significantly compared to the local oscillator. As a matter of fact, it's between 80 to 100 megahertz for FM and 80 to 400 megahertz for AM. So maybe I'm not reading something right. Maybe there's a little bit more to it, but it sounds like what they are really emphasizing is the low noise benefit of using the crystal oscillators. I'm not quite sure. We're going to have to dig into that. Again, this is why we need to span this series over multiple videos, because there's going to be a lot that we're going to learn. There's no real point in me telling you how this thing works right now and showing you the whole manual of arms, because I guarantee you by the time we're done with this, I'm going to have an awful lot of things to add to that sort of description, and probably a whole lot of corrections that I would have to make to this video if I tried to explain how it worked today. It's kind of difficult to assign a dollar value to one of these units. There's a few of them up on eBay for sale that are currently in the range of $200 to $300 excluding shipping, at least at the time I'm making this video in July of 2026. However, those listings have been active on eBay for a very long time with no takers, and there haven't been any of these actually sold recently on eBay. So there's no data on what people are actually willing to pay. There's only data on what people think they are worth. I, on the other hand, got this one for $60 Canadian, and of course there was no shipping as it was a local classifieds item. There was even free delivery to the door, courtesy of the guy who was selling it. So as far as burning $60 goes on an impulse buy, I think this is a pretty good way to do it. The previous owner mentioned that the unit is working, at least in some capacity. They had actually used it as a makeshift radio receiver, which isn't, of course, the intended use case for it, but it does at least give me a couple really helpful clues. The first one being that the RF front end is probably alive and working if it was being used for that, and tells me that the general bones of the system are probably fine. Of course, we'll be able to verify that later on. So what does this unit actually net me? What am I able to do now that I have one of these? Well, I can measure things like the amount of modulation coming out of a radio. I can measure deviation, a couple useful things. And honestly, for $60, if this thing works, or if I can get it to work for not too much extra money, I'm quite happy to just let it sit on the bench unused for a fairly long period of time until its moment to shine comes along, when all of a sudden I really need one of these, and I do happen to have one on the bench. Despite the fact that the previous owner mentioned the unit was in working condition, I don't want to just take that on faith and assume that everything is fine. For all I know, there's a capacitor in there that's about this far away from being ready to explode. So we're definitely going to give this the full sort of audit before we actually try and do anything with it. Basically, our order of operations, so to speak, is we're going to try to get a rough idea of what the current state is. We already understand the prior state, the description that the previous owner gave us. So we know that if we did just flick it on, we should expect the RF front end to work. We should be able to have that part of the unit working. We wouldn't necessarily expect things to be calibrated and aligned. Of course, that would be pretty luxurious if it already came pre-calibrated after it is probably 50 plus years old, so I don't expect that. I'll be happy if it doesn't explode. The next thing that we're going to do is photograph absolutely every square inch of the unit, and the reason I do that is twofold. The first reason, which is by far the most important, is that you need to know exactly how this unit was assembled and put together, because as soon as you start removing screws, you never know how deep a disassembly is going to go. It may seem like it's going to be a really quick adventure and you're thinking, oh, please let this be a normal field trip, but all of a sudden you've got this whole unit apart in 100 different pieces and you have no idea how any of it went back together. Your memory was not as good as you thought it was going to be. So by having really thorough photographs of the whole unit inside and out, that prevents a whole series of headaches that can occur where you don't know which screw went where, you don't know which wire connected to which circuit board, if you have to take something out and desolder it and then put it back in. So I generally I don't even open something until I've got 100 photographs of it, and that sounds kind of maybe a bit overkill, but it's really saved my butt quite a few times, and so I do it regardless. The other benefit to that, the second reason I like to do it, is because with these older units, even this isn't some obscure unit where they only produced 10 of them and that sort of thing, but No one bothered to really go and photograph all of the internals and even the front panel like in really high detail. You'll get a couple photos of the front panel usually either from an eBay listing or some website that archives and catalogs these units. But if you're wondering, like where did this part go? Where did this thing, how did this thing get put together? You're really not likely to find some nice high resolution close up of the exact part of the unit that you're curious about. And even if you found some internal photos, it might not be for the exact same variant that you have. The TF2300B is fairly common, but the TF2300BM seems to be a lot less common for some reason. As a matter of fact, the marking here for the M appears to be in a different font than the rest of this labeling here, almost as if it was added on after the fact. So it may be a very small difference between the two models, but even if someone took some really nice photos of the inside of a TF2300B, you might be looking at that and then looking at the inside of this and realizing all of a sudden they're actually kind of different once it comes down to trying to reassemble something or replace parts and that sort of thing. So I pretty much don't even take out a screwdriver until I've got like 100 photos of the entire unit. When we're photographing the unit, specifically the insides and the electronics and components and that sort of thing, we're essentially completing two different steps at once, because those photos are also going to be used for assessing the state of the internal electronics and highlighting any capacitors that might need replacing or anything odd that might show up. And it can be really useful to have high quality close-up photos with some good magnification that can help you sort of identify, hey, is that a bit of corrosion on the PCB, or is that capacitor looking like it's starting to leak, or is that just some flux residue? You can answer all sorts of questions by having those photographs. And you have to inspect the thing anyway, so you might as well take some photos while you're doing it so you can at least figure out how to put it back together. Then, by the time we've done our inspection of the inside, we're kind of going to have a go or no go sort of decision to make about whether or not we feel like this can be powered up safely, um, or whether it's best to leave it off, replace some things inside, or perform some other kind of maintenance. After we've done the inspection phase and taken a look at everything, we're essentially going to have a go, no go type of decision to make about whether we think the unit is safe to power on the way it is, or whether it's better to just leave it off, wait for some new parts to arrive, and that sort of thing. Even if we're not able to power the unit on right away, there's still plenty of things that we can do. There's definitely some deferred maintenance that needs to be done. The manual does cover some routine maintenance about the cleaning and lubrication of these rotary switch contacts, and I can guarantee that that hasn't been done recently. So there's some things that we can still do with this, even if we don't get to power it on and see it all light up. When it does come time to power this unit on, unfortunately, the one thing that I won't be able to do in the short term is calibrate and align this unit. That's because there are at least two pieces of equipment that I currently don't have, which I need in order to do the alignment. Remember when I said that this unit wasn't exactly the highest priority item for my workbench? Well, it just so happens that the two highest priority items are a signal generator and a frequency counter. And wouldn't you know, those are two items that I need in order to do the calibration on this, which makes sense. They're pretty common pieces of equipment for that sort of thing. I actually have a frequency counter in the mail. I found a good deal on one coming from within Canada, and it's literally going to arrive tomorrow. So that's great, but I have absolutely no leads on a signal generator. I'm trying to find something used that's relatively affordable, but also has kind of enough features that I'm not going to be needing to turn around and replace it. And that's totally in the wind. So the most that we're going to be able to do in the short term in order to suss out whether or not this works as an actual piece of measurement and test equipment is to take some known good radios that have left the factory within the last 5 years and not the last 50 years, and measure their modulation. And if we see some relatively normal results, especially across multiple radios, then we can kind of piece together that the unit probably is okay and just needs the additional calibration. So in the next coming videos, we're going to take a look inside the unit and do an inspection, see whether or not the unit is safe to power up, whether or not there's anything suspicious in there in terms of capacitors and whatnot that may need replacing. We're going to photograph every square inch of the unit, although I'll do that off camera, mostly because I kind of need this camera to take the photographs. And then eventually we'll work our way up to a first power on, and of course discuss the operation of the unit. So there's certainly lots to look forward to in the videos to come in this series. Hopefully you've enjoyed this brief sampler, for lack of a better word, on what this project will entail. As always, thank you very much for watching. This is VO1RFX, and this is what was on the bench today.